All right, today we're gonna crack open one of nature's absolutely coolest designs, the turtle shell. I mean, you look at it and you think, it's a house, right? But it's so much more than that. It's a biological fortress, a masterpiece of evolution that's been in the works for 60 million years. So how does this thing really work? Okay, let's just get the big question out of the way first, the one we've all seen in cartoons. A turtle gets spooked and whoop, it just pops right out of its shell and runs off. It's a hilarious image, but you gotta wonder, is there even a tiny bit of truth to it? Can a turtle really just pack up and move out? So the short answer to that is a huge, definite no. A turtle leaving its shell would be like you or me deciding to just step out of our own skeleton. It's not a piece of clothing, and it's definitely not a convenient little backpack. It is a living, breathing part of its body. To really get why a turtle and its shell are totally inseparable, we need to take a closer look under the hood. The anatomy that makes a turtle is honestly brilliantly bizarre. You see, the shell is made of two main parts. That top domed piece is called the carapace. And get this, it's actually the turtle's rib cage and spine all fused together into one solid plate of bone. Then, the flat part on the bottom, the plastron, is made from its chest and shoulder bones. So the shell is the turtle skeleton, just on the outside. So yeah, asking a turtle to leave its shell isn't like asking it to leave its house. It's like asking you to just, casually slip out of your own rib cage for a minute. They aren't just attached to each other, they are literally one and the same thing. And this incredible piece of biological engineering, well, it didn't just show up overnight. This was a massive construction project that was tens of millions of years in the making. The whole journey started way back, about 260 million years ago, with an ancestor called Unnotosaurus. It had these wide, flat ribs, kind of the first hint of a shell. Then, fast forward 40 million years, and you meet Odonchellus. This guy had a full-on plastron, that belly plate, probably to protect it from predators attacking from below. But look, it still didn't have a top shell. It was a turtle on the half shell. Finally, around 200 million years ago, Progonocellus shows up with the first complete, fully fused shell that we would recognize today. That's 60 million years. Just let that sink in for a second. It took longer for the turtle to build its shell than the entire time that has passed since the dinosaurs went extinct. This was a slow, careful, and ultimately world-changing renovation. So, after a 60 million year project, was it worth it? Oh, absolutely. The shell gave turtles a set of superpowers that helped them outlive countless other species. First and foremost, the shell is a nearly impenetrable fortress. Predators just can't get through it. Turtles can pull their soft, vulnerable head and limbs right inside for total protection. But it's more than just armor. It's also fantastic insulation, protecting them from crazy temperatures. And in the water, it gives them stability and helps them float. It is a true all-in-one survival tool. And what's really cool is how evolution has customized this design. Land turtles or tortoises, they often have these high, domed shells. That makes it super hard for a predator to get its jaws around them and pretty much impossible to flip over. But sea turtles, they've evolved these flat, lightweight, streamlined shells that are absolutely perfect for gliding through the water. It's the same basic concept, just with totally different applications. But, carrying your house and your entire skeleton on your back all the time, it comes with some serious downsides. This fortress has a few major trade-offs. For starters, it's just incredibly heavy. That's a huge reason why land turtles are so famously slow. They're lugging around a massive burden. This rigid, bony box also puts a hard limit on how many eggs a female can carry because her body simply can't expand. And just growing and maintaining this bone armor for their whole long lives takes a gigantic amount of energy. But maybe the wildest challenge is just breathing. Think about it. You and I breathe by expanding our rib cage. A turtle can't do that. Its ribs are part of the shell. So how does it breathe? In a truly mind-bending adaptation, it uses special muscles to basically squish its internal organs against its lungs to push the air out. Then it relaxes everything to let air back in. It's this super complex and unique solution to a problem the turtle basically created for itself. For all the amazing protection the shell gives an adult, it can't really help a baby turtle in its first, most dangerous moments of life. And this is the story of a frantic dash against absolutely impossible odds. 1 in 1,000. Yeah, those are the estimated odds of a sea turtle hatchling actually surviving to become an adult. From the very second they hatch, they are thrown into one of the most dangerous races in the entire animal kingdom. Guided by pure instinct and the faint light of the moon on the water, hundreds of these tiny hatchlings just erupt from their sandy nest all at once and begin a desperate scramble for the ocean. It's this big, synchronized event, a strategy to try and overwhelm the predators with sheer numbers. And trust me, those predators are everywhere. The beach becomes a gauntlet of hungry crabs and diving seagulls. For them, a turtle hatching is like an all-you-can-eat buffet. And the hatchling's little shells are still way too soft to offer much protection. And if a hatchling is lucky enough to make it to the waves, the danger is far, far from over. Now, a whole new set of predators is waiting. Big fish, sharks, you name it. The first few hours of a turtle's life are just a relentless, non-stop fight for survival. So when you see this incredible struggle, and you know those terrible odds, it leads us to a very modern and very human question. I mean, it feels almost instinctive, right? You want to step in, clear a path, and make sure these tiny little creatures make it to the sea safely. But is that always the right thing to do? The answer, just like nature itself, is really complicated. On one hand, there's a really strong argument that we should intervene, especially when the threats aren't even natural. Artificial lights from hotels and houses can completely disorient hatchlings, making them crawl away from the ocean. Plastic trash can be like an impossible obstacle course. In those cases, helping is really just correcting a problem that we created in the first place. And for critically endangered species, every single hatchling can make a huge difference. But on the other hand, there's a very compelling case for letting nature take its course. That mad dash to the sea is part of a delicate ecosystem. The hatchlings that don't make it become dinner for crabs and birds, which depend on this seasonal event. So by helping, we might actually be starving another species. We also get in the way of natural selection. That tough journey ensures only the strongest and luckiest survive, which is what keeps the turtle gene pool strong for the future. In the end, the turtle's incredible shell, this product of 60 million years of evolution, is now facing a brand new test. It can protect a turtle from a shark, sure, but it offers no protection from a floating plastic bag or a confusing streetlight. So the real question for us isn't just whether we should help, but how we can create a world where this ancient survivor doesn't need our help to begin with.